Article 220.12 of the 1999 National Electrical Code, or NEC, addresses the calculation of loads for lighting track. Importantly, the 1999 NEC removed the provision that allowed for an equal distribution of the load among the circuits of a multi-circuit track. Prior to this change, specifically in the 1996 NEC, Article 410.102 stated that the load could be considered equally divided. The current requirement necessitates calculating the load based on the actual demand of the system rather than assuming an even distribution. This adjustment in the code acknowledges that the load distribution on multi-circuit track lighting is often uneven. This unevenness can stem from a variety of factors. Firstly, the spacing of the lighting fixtures along the track may not be uniform. If fixtures are clustered in one area, that circuit will carry a higher load. Secondly, the wattage of the lamps used in each fixture can vary. If some fixtures use higher wattage lamps than others, the circuit serving those fixtures will experience a greater load. Thirdly, the type of load connected may vary, such as lighting, small appliances, or other loads permitted to be connected to the track. The electrician is responsible for accurately calculating the total load in the multi-circuit track lighting system, taking into account the individual loads connected to each circuit. The calculation must consider several factors. Firstly, the number of fixtures connected to the track must be determined. Secondly, the wattage of each lamp installed in the fixtures must be identified. Thirdly, the spacing of the fixtures along the track should be assessed to identify any potential imbalances in load distribution. The NEC provides guidelines and formulas for calculating branch circuit loads, and these should be applied to each circuit of the multi-circuit track. An electrician must ensure that the calculated load does not exceed the ampacity of the circuit conductors or the rating of the overcurrent protection devices. If the calculated load exceeds these limits, adjustments must be made to reduce the load, such as using low wattage lamps or redistributing the fixtures more evenly along the track. It is important to note that the NEC requires that all electrical work be performed in a safe and workmanlike manner. This includes following all applicable codes and standards. When installing multi-circuit track lighting, electricians should carefully review Article 220.12 and other relevant sections of the NEC to ensure that the installation meets all requirements. To ensure accurate load calculations, it is helpful to follow a systematic approach. 1. Gather all necessary information about the track lighting system, including the number of fixtures, the wattage of each lamp, and the spacing of the fixtures. 2. Calculate the total wattage of the lamps connected to each circuit. 3. Determine the amperage draw of each circuit by dividing the total wattage by the voltage of the circuit. For example, a 120 volt circuit with a total wattage of 1200 watts would draw 10 amps. 4. Ensure that the calculated amperage does not exceed the ampacity of the circuit conductors or the rating of the overcurrent protection devices. 5. If the calculated amperage exceeds these limits, make adjustments to reduce the load. 6. Document all calculations and keep them readily available for inspection. In addition to following the NEC, it is also important to follow the manufacturer's instructions for installing the track lighting system. The manufacturer's instructions may provide additional guidance on load calculations and other installation requirements. Failure to follow the manufacturer's instructions could void the warranty on the track lighting system. When designing a multi-circuit track lighting system, it is important to consider the potential for future expansion. If you anticipate adding more fixtures to the track in the future, you should design the system with enough capacity to accommodate the additional load. This may involve using larger conductors or installing a larger overcurrent protection device. It is also important to consider the energy efficiency of the track lighting system. Using energy-efficient lamps can help to reduce the overall load on the system and save energy costs. Light-emitting diodes, or LEDs, are a popular choice for track lighting because they are very energy efficient and have a long lifespan. In summary, the 1999 NEC requires that the load on a multi-circuit track lighting system be calculated based on the actual load on the system, rather than assuming an even distribution. This change was made to reflect the fact that the load on a multi-circuit track lighting system is not always evenly distributed between the circuits. By following the guidelines in the NEC and the manufacturer's instructions, electricians can ensure that multi-circuit track lighting systems are installed safely and in accordance with the code. When performing load calculations for track lighting, it is important to differentiate between branch circuits and feeders. Branch circuits supply power directly to the track lighting, while feeders supply power to one or more branch circuits. Load calculations for branch circuits must be performed according to Article 220.12 of the NEC, while load calculations for feeders must be performed according to Article 220.80. Demand factors can sometimes be applied to lighting loads depending on the occupancy and the type of lighting. Demand factors are multipliers that reduce the calculated load to account for the fact that not all of the lighting will be on at the same time. The NEC specifies the demand factors that can be applied to different types of lighting loads. It is important to understand the different types of track lighting systems available. There are line voltage track lighting systems which operate at 120 volts or 277 volts, and low voltage track lighting systems which operate at 12 volts or 24 volts. Low voltage track lighting systems require a transformer to step down the voltage from the line voltage. When installing low voltage track lighting, it is important to ensure that the transformer is properly sized to handle the load. The NEC requires that all electrical equipment be listed by a recognized testing laboratory. This means that the equipment has been tested and found to be safe for its intended use. When selecting track lighting equipment, it is important to choose equipment that is listed by a recognized testing laboratory. Branding is an important safety consideration when installing track lighting. The NEC requires that all metal parts of the track lighting system be grounded to prevent electric shock. The grounding conductor must be sized according to the requirements of the NEC. Overcurrent protection is another important safety consideration when installing track lighting. The NEC requires that each branch circuit supplying track lighting be protected by an overcurrent device, such as a circuit breaker or fuse. The overcurrent device must be sized to protect the circuit conductors and the track lighting equipment. The location of the track lighting system should also be considered. If the track lighting system is installed in a damp or wet location, such as a bathroom or kitchen, it must be listed for use in damp or wet locations. The NEC also has requirements for the spacing of track lighting fixtures. The fixtures must be spaced so that they do not overheat and so that they provide adequate illumination. When installing track lighting, it is important to follow all applicable codes and standards. This includes the NEC, as well as any local codes or ordinances. Failure to follow the codes and standards could result in a fire or electric shock. Regular inspection and maintenance of track lighting systems are important to ensure their continued safe and reliable operation. This includes checking the fixtures for damage, tightening any loose connections, and replacing any burned out lamps. When working on track lighting systems, it is important to always disconnect the power before performing any work. This will help to prevent electric shock. If you are not comfortable working on electrical systems, you should hire a qualified electrician to perform the work. When designing track lighting systems for commercial applications, such as furniture showrooms, it is important to consider the specific needs of the space. This includes the type of merchandise being displayed, the desired level of illumination, and the energy efficiency of the system. Track lighting is a versatile lighting solution that can be used in a variety of applications. By following the guidelines in the NEC and the manufacturer's instructions, you can ensure that your track lighting system is installed safely and in accordance with the code. Always consult with a qualified electrician for any electrical work. Consider the ambient temperature when calculating conductor ampacity, especially in enclosed spaces or areas with high temperatures. Correcting ampacity for ambient temperature ensures conductor insulation is not compromised. Also, consider voltage drop, especially for long circuit runs. Excessive voltage drop can cause lights to dim and equipment to malfunction. Calculate voltage drop to ensure it remains within acceptable limits per NEC recommendations. In addition to calculating the load for the track lighting, You must also consider any other loads that are connected to the same circuit. This could include receptacles, appliances, or other lighting fixtures. The total load on the circuit must not exceed the ampacity of the circuit conductors or the rating of the overcurrent protection device. The NEC provides tables and formulas for calculating the ampacity of conductors and the rating of overcurrent protection devices. It is important to use these tables and formulas to ensure that the circuit is properly protected. When working with electrical systems, always use appropriate personal protective equipment, or PPE. This includes safety glasses, gloves, and insulated tools. Never work on electrical systems while standing in water or on a wet surface. If you are not sure how to perform a particular electrical task, consult with a qualified electrician. Remember, electrical work can be dangerous if it is not done properly. Always take the necessary precautions to protect yourself and others. In addition to the NEC, there may be other codes or standards that apply to the installation of track lighting. These could include local building codes, fire codes, or energy codes. It is important to check with your local authorities to determine which codes and standards apply to your project. Staying current with the latest edition of the NEC is essential for all electrical professionals. The NEC is updated every 3 years, and each edition includes changes and revisions to the code. It is important to be aware of these changes so that you can ensure that your electrical work is in compliance with the latest requirements. There are many resources available to help you learn about the NEC. These include textbooks, training courses, and online forums. You can also consult with a qualified electrician or electrical inspector. It is also essential to ensure compliance with Americans with Disabilities Act, or ADA, guidelines regarding lighting levels in commercial spaces to ensure accessibility and safety. Careful planning and consideration of these factors contribute to a well-designed and compliant track lighting system.